Well, let's turn now to working a few example problems. And the first one is find the total force on the U-shaped wire carrying the current I in the external uniform magnetic field B naught equal minus B naught. B naught is positive here in the Z direction. And you were given a coordinate system associated with it. I guess it's really, in this case, an upside down U in our case. Uh, the direction of the magnetic field was given to be in the minus B naught, and so if this is x coordinate, y coordinate, then z is coming out of the page, so the positive z axis is out of the page toward me, and so this magnetic field is into the page. We've got some dimensions on this U. The dimension vertically is on these legs is A, and the width of the U is B. Uh, I guess you could call it an N here too in a certain sense, but usually called a U shape. So we have that basically given. And well, what do we do in this? Well, we've got a nice uniform field, and we've got all straight line segments. And so I'll divide this up into the straight line segments and do each one in turn, and use the magnetic force on a current carrying straight line segment of a wire carrying a current I in an external uniform field. And the one thing to point out that this obviously can't be all of the circuit, because I can't have current that just miraculously appears here and comes around here and then miraculously disappears. So this is obviously some piece of a larger circuit, and I'm only analyzing, trying to get the total force on just this piece of the wire that's, I'll assume, is stiff and is bent in that shape, and it can't be deformed by the forces that we'll have on it. And so what I do is I want to get the total force. So what I'll do is I'll get the force on the right hand side plus the force on the top plus the force on the left. Now you don't have to, but I generally start over here and go in the direction of current flows. And that's what I did, I think. Yeah, that's what I did on this. And general formula, this will be on the left-hand side, is the current going in it. Well, the current is I. The L is the total length from one end up to this corner. And then, of course, it's in this uniform field. And I can really pin that down with this coordinate system, because L vector is just the total length, A, and its direction is in the same direction the current's flowing, and that's in the positive y direction. So L vector in this case is A j hat, and that has to be crossed into the magnetic field. Well, the magnetic field was given, it was in the minus k hat. I can pull out all of these constants. They've come through nicely, these vectors. Minus I, A, B naught, the minus sign from here. And then I've got J hat cross K hat. And if you look at it, J hat cross K hat is, in fact, I hat. And so the force on this left-hand side is a force pushing it to the left here, going in the minus I hat direction. I can do a similar thing for the top. Let's look at the top. And the top, again, same formula. I just have to use what I know about the top here. Uh, the top is just this piece here at the top. L vector, well, it's the total length, B, and its direction is the direction the current's flowing, and in that case that's in the positive x direction, so L vector is B I hat for that straight line segment. Magnetic field hasn't changed, it's minus B naught to K hat, and then I'm off and running and doing as before. Pull out the I, pull out the B, pull out the minus B naught, so I get all of these things. And then I hat cross K hat, and I hat cross K hat is minus J hat. You look up here, I hat cross K hat, so that's going to be, if you use the right hand rule, Z is coming out of the page at me. is going to be downward, which is in the minus j hat. So I get minus j hat for this I hat cross k hat, and a minus is a plus, and so that one is in the all of these quantities here being positive is in the positive y direction. So the force on this top portion here is strictly straight up. And then finally on the right side, that's over here. Notice now the L vector has length A and it's going in the minus j hat. A and the minus j hat. B is the same, that was given to us. Minus is a plus. I can pull out the I, A, and B naught all to the right, and I'm left with j hat cross k hat. And j hat cross k hat is I hat. I hat is in the positive x direction, so the force on this side is to the right. The force on this side, the left, is to the left. The force on the top is upward. And now then you just add all those up. The right side was this, left side was this, and then the top was this. And then pretty obviously the right and the left have the same magnitude and opposite direction, so those vector pieces will cancel. And I get the total force in this particular case is all upward with magnitude I, B, and B naught. Well, that's a use that you'll often have for getting the force, and we'll see some applications of that a little later this week, I think.